Okay, welcome back, everybody. I don't think the microphone is picking up when my phone is buzzing, but boy, having Microsoft Teams and thus an instant message system with colleagues seemed like a great idea. But here we are. Anyway, all of these things are important. I just don't want to hear about it when I'm recording a lecture. All right, so we were let's look here. So again, a couple things that, again, were by far the thing that I see most often that is, I guess, under control of the developer is this insufficient authorization, because frankly, the authorization check is inherently a question of your system. Like you can, in an automated way, prevent cross-site scripting. All output gets escaped, like a nice, easy, safe default. Authorization, who should be allowed to view this URL on your site? Only you know, because only you know what site you're thinking of. And again, should an account owner have a boss that's allowed to view the thing or whatever? It depends on the site. So again, part of the reason this is done, or has to be, or programmers have to worry about it, is it's just like I've seen things that promise our framework does authorization safety. I'm very suspicious of that claim, because authorization checks are so arbitrarily complex. Maybe a framework can help you with some basic things, but in general, you got to be a programmer at it. Okay, sessions. So again, this is one that's less common to sort of see people do, because sessions are probably going to be handled by not you, by the framework. So to start with here, is the question of what's a session. Fundamentally, before we add anything else, HTTP, as we've described it, is stateless. A request comes in, you respond to it on the server. All of those are independent. There's nothing so far, at least, to say this request is from this user who logged in 20 minutes ago. But of course we need to do that, right? We need to be able to go to courses or whatever and be logged in or not, as the case may be. So there's some kind of session token that's going to keep track of that, which is basically, so session is between me and the server, between the user and the server, there's some tracking of who is this person. Oh, this is the person that logged in 20 minutes ago as GG Baker. Okay, now we know who they are. So in HTTP, that token is almost certainly carried by a cookie. And this is the basics of what's going to happen. When you logged in or whatever, the server sent, so this is a response header, server to client, hey, client, remember this. Remember this is the way, this is a string, I guess, that I'm going to ask you for later. And only send this string to example.com. Don't go sending it to other people or whatever. And then every time the browser comes back and makes another request to that server, it's going to send this, right? So if this string is somehow identifying, as far as the server is concerned, then we can keep track of, okay, this person, this user, browser session, whatever it is, we can keep track of them. And I mean, for many reasons, but probably they have logged in is the most obvious one. This session ID is associated with a nice secure, they entered their password, I trust them, that happened a while ago, I know who this user is. So this becomes a security problem. Well, what if you know that? What if you can guess that? Some other user can come along and say, you know what, I'm going to try to send session ID 034DEDA7, whatever. Well, if you can send that cookie, then you're me. So there's sort of two sides to this. So again, that's the session. I guess the two ways this can go wrong are prediction and hijacking. So prediction is, well, something that should not be a thing, right? So I hope you all agree that this would be a really bad cookie to send, right? If I go along to the site, I type my username and password, I'm dutifully authenticated as GG Baker, this is a really bad cookie to send because it's not very, you don't have to be very clever to predict like what cookie do you have to set to be that user. Well, it's a username. You also want the sort of space of all possible user IDs to be pretty sparsely used, right? You don't want to be in this situation where you have like, you know, if I guess I'm imagining here like an auto increment primary key that's just like, well, you get session ID 82. Well, I bet if I got 82, you know, like that's a pretty small number. I predict that I can also try session ID 81 and just become some other random user that was logged into your site. So whatever kind of goes here, like whatever value is used to identify the user, can't be predictable. That's not too big a deal. If there's something bad about your random number generator, like assuming you're doing something like what kind of randomness can I rand bytes? That seems like a lot of randomness, right? Okay, so I generate some random bytes like that and somehow use that to generate, you know, I base 64 encode it or whatever. Okay, so that's a lot of randomness, 64 times 8 bits worth of entropy. But the question here is like, how good is my random number generator? The random number generator that you need for like, where does the monster appear in the game? I don't want it to be too predictable. And the random number generator you need for like this application are different. So, you know, properly seeded random number generator that has a true random source. Well, again, like, so I have a Ruby example here, this secure random module. I don't rightly remember, like I would have to check in Python, you know, how was my random number generator seeded here? Is this a cryptographically secure collection of random bytes or not? I'd have to go to the docs and check. But fundamentally, probably not your problem. But again, I guess the thing that then has to happen is on the server side, you need a table in your database that's like sessions, session ID that's indexed, and then like what user is logged into that session. So you can look up like, okay, well, I found a user with this session. Then you can look up in your database, who are they? Fundamentally, again, probably not your problem. Let your framework do it. If your framework doesn't do it, find a framework that does. These things are subtle and can be tricky. So the other side of this, so again, we get prediction out of the way by having something that's not possible to predict as your session token. Hijacking is, well, I'm not predicting it, I'm just finding it. Like, look, there it is, it was on the slide. If this was a session token and you can see it, and you can see it in the browser history, you can, you know, if you work for TELUS, you can see all of my traffic go by, maybe it can be snooped, you can snoop on insecure Wi-Fi, like all of those things where I don't have to guess it, I can find it, are still open, right? It's still, if I come along and I say, my session ID is this, the server is going to believe me. This is, in some ways, this is where like HTTPS, the encrypted version of HTTP becomes a thing to worry about. Let's see what OWASP says about this subject. So wait, this is, again, this is a broader category of identification and authentication failures. Yeah, even just, yeah, weak or well-known passwords. Yeah, you shouldn't be having those. Exposes session identifier in the URL. Good, that's my first point. Once in a while, you will see that kind of thing where you will see a URL that's like, there's some text editor, yeah. Well, you know, something like this. Well, anybody standing over my shoulder can see that, or, you know, if I'm doing a screen recording, or it's in the logs for the for that client or whatever, right? All of these ways that somebody could see that if it's actually part of the URL. Some older frameworks do this. Stretch did it sometimes You don't see it much anymore because it's just not the right thing to do. Cookies can and should expire, right? Like your session shouldn't last forever, either on the server side or in the cookie. So, I've said here this, like probably the cookie should expire after a certain time, but also in your database of here's all the sessions I know about, there should be an expiry time there. And after the expiry time, you just don't accept it anymore. So a user can be logged in for 2 weeks at most or whatever. Or there should be a like explicit logout, right? So fundamentally, if as a user, if I click the logout link, really what I expect is, well, whatever session token I'm sending, delete it from your database. Should no longer be the case that the session token that I'm thinking of is associated with me, the logged in user, because I'm going to walk away and this is my friend's computer or whatever else. And like I said, the S in HTTPS, that things should be encrypted, prevents the like insecure Wi-Fi or malicious TELUS network administrator or whatever from seeing this traffic go by, because it's encrypted between the browser and the server. There is this parameter that you can send on the cookie. So again, when the cookie is being sent initially from server to client, you can say, okay, well, the session ID equals this, and only send it to this domain because I'm the one keeping track of it, and it expires in a couple weeks, and only don't send this by HTTP non-S, which is what this argument means. So this can be done. It's the reason for the, you want to see HTTPS basically anywhere you're logging into. You should be seeing secure HTTP, encrypted HTTP. And you kind of hope that the developers have sort of turned on all of these things in their session management package. Like I said, this is probably not something you have to worry very much about because your framework is going to do it. But I don't know, Rails sessions, like somewhere in here, see, there's a config. If you've done Rails stuff before, did you say that? And I assume this is putting the secure argument on a parameter on a cookie. I would have to check, like I would have to, have a much closer read of the docs than I'm about to in the next couple of seconds. Before I really trusted my ability to configure sessions in Rails. But you better make sure I do it right. And I'll come back to that. Okay. Crosssite request forgery. Does this lecture have just a lot of things that are difficult to say, or am I just speaking poorly today? Anyway, CSRF, let's call it. Is something I think, I stand by this. I think this is more true than it was a few years ago, or like more developers understand CSRF than they did a few years ago. But this is what can happen. Okay, I am running example.com. I am interested in example.com being secure and safe, and that my users are, their information is secure and everything else. Okay. My session's working, everything's great, I'm using HTTPS, no problem. This person has logged in. You have logged into my site. Okay, but you also went by this other site. I'm not in control. I have no influence over every other website on the internet. So somebody else, okay, you could put the S in there. Like I've written it as if I'm using HTTP, but that could be HTTPS, probably should have been. But this is a perfectly legal form action for their website. Somebody can do whatever's going on here and arrange it so that, presumably, I guess the way I've written this is change my password to this value. It's a hidden input. The user can't see it. You make it look like a search box. Okay, they're going to type their search term and press search. I don't care about that. I'm just trying to change their password in some malicious way. Or a bad guy is trying to change their password on my website. So the user, you see this. It's a search box. You type your search term, you click submit. Okay, then my site gets a post request to this URL. That's what's been what has been requested here. Password change, and you see whatever fields you expect here. Change my password to this, and okay. What I see from the example.com perspective is a perfectly legitimate session, right? So the browser is going to request this URL with the session ID of you have logged in correctly. Okay, is this who they say they are? Yes. What have they asked for? They've asked to change their password. I changed their password. Something about this story has to not happen. One of these steps has to break. If it's a GET request, it's even easier. Any image source is a GET request. So if I want to trigger a GET request on somebody else's website, I don't even need them to click that button. I can just have an image, and their browser will request that URL as a GET request. Or if somebody's discussion forum that allows image embedding, you can do the equivalent of that. So how do we prevent this one? Really don't want this, again, arbitrary action the user can click on and have it happen. Two things here. I swear I checked that link an hour ago. Anyway, I'll try to fix it. Sorry. So for GET request, this is GET request shouldn't have side effects. Don't let your GET requests have side effects. Right, so something like this, okay, this is annoying in that there's a GET request coming in for my site and it's expecting an image and it really shouldn't be, and that again could be a denial of service kind of thing, but we're not actually going to change a password as a result of a GET request. So fine, you made a request that's annoying but not dangerous. For a post request, you sort of have to, like, what I really want here is if a user is going to change their password on my site, or again, if, substitute any other action the user might take. But if the user is going to change their password on my site, I want them to do it from my change password form, not from something that somebody else created, not from somebody else's form. And the defense here is to have another token, Crosssite request forgery specific token, that is rotated often. It could be for every page. I think it's typically for every session is often enough to ensure things are secure. But there's this secret, and I don't tell the user this like explicitly. It's not like they know this or it's a password. It's not the session cookie. The only way this is known is because it was, I generated this HTML form. This is my password change form. I generated this with a hidden input that has this CSRF token. Again, this was a random thing I just generated. So if the user submits the form with CSRF equals this number, great. Then I know they've come from my form, because the only way to produce that value is to come from my form. Back here on badguy.com's form, they don't have that, and they don't know that secret CSRF token. So we're going to block, somewhere in these last few steps, we're going to say, the CSRF token wasn't right on that form. So we're going to fail on that. And again, it's easy to say, but now like every form, I guess, that is a post request on your entire site has to have this other token associated with it. And it has to be like part of your template or whatever to produce. Maybe this is the link that I checked. This is another one where your frameworks can help. You have to know. For something like Django, there is built-in CSRF protection. You have to turn on the middleware that's going to check, like, when a post request goes by, it's automatically checked before it ever gets to any code you wrote that the CSRF token is correct. You have to put this in all of your forms. Not a big deal. But once again, it's so much easier to do this if you do it from the start. if you have to retrofit an existing site, it's going to be a pain, and you have to get it right again in every spot and sort of test it in every spot. If it's there as part of your site's default behavior, it's going to be much easier to get right because you're going to do it as you develop. I guess I also like the Rails site here. It has a reasonably good diagram on the subject. The hacker is making a request. Again, they're picturing this as a GET request. But the same kind of thing happening here. There's some kind of token that you can insert in forms and stuff that I'm not going to randomly scroll until I find it. Okay, this is the OWASP CSRF cheat sheet that I probably was thinking about here. Again, conceptually easy to deal with. You just have to know to deal with it and turn it on. The defaults here, I guess it depends on the system. So I think in every framework, CSRF is going to be off by default, but it might be turned on like when you do the equivalent of like scaffolding or something. Like when you create a new project, the files that are created might, if you create a brand new project, might default to on because it is the right thing, but old projects default to off. But again, you have to know to look for it, make sure it's on in the right spots. Wait, what just happened? Is CSRF not here? So yeah, I think, yeah, CSRF is not in the OWASP top 10 for whatever reason. I think it's counted as like a subcategory of one of the other ones. Maybe broken access control or something. We do not mention CSRF on that page, at least. But again, I'm mentioning it as separate because it is something that as a developer, you have to worry about as a separate problem. I'm not gonna sit here and read that page. I have faith in your literacy. Okay. Again, so this is another one where it's a separate, like it's not listed here because it's part of I don't know, identification and authentication failures or something, but it's very easy to do as a developer, so I'm going to mention it as a separate thing. And this is like, you're going to let the user upload like a profile image, like an avatar of like, here's what I look like, put it beside all of my blog posts or whatever. Most frameworks allow some pattern like this, which is, okay, we're going to have a file upload thing. When you do a file upload thing, it gets stored here in this directory or in this S3 bucket or whatever, file-like thing. And then you just serve it as static, like you have a file on a disk. You want to give the user that comes along later, you want them to look at that file. Well, you let Nginx serve it because it's a file. Let's just treat it like a file and have it be static content because that's faster and easier and I don't have to write any code. And if you're happy with that, then that is faster and easier and you don't have to write any code. But then you also don't have any way as a developer to do authorization checks. So if instead of an avatar image, we imagine this file is a document for, it's a PDF document where I've scanned my birth certificate or, whatever. It's still a file. I'll still store it on disk, but I really, really want that authorization check. Only the user themselves should be able to see that file, or only the user and the receiver of that submission or whoever it is. I, as a developer, need to do that check. So this is, I think, probably the best solution here, and the solution at any reasonable scale. So, we forget about like Facebook and like LinkedIn and stuff in this story, and we say, okay, well, for everybody else, we're just going to have a controller, right? So the same way that I checked logic back however many slides that was. And I said, if, whatever the equivalent of this is this person allowed to actually see the thing or not? I write, the 3 lines of code or whatever it is that say, okay, well, instead of allowing these files to be served as static content, get them away from Nginx or Apache or IIS or whatever, move them into some private directory, and have a little bit of logic that I wrote deal with it. Check that authorization and send back the response. It's like, here's your PDF document file. This can actually be quite quick. There are these most frameworks have some kind of raw file sending function that bypasses some of the overhead that you usually have for sending a response. But there's some overhead there. You still have some Python, PHP, Ruby code, whatever it is, in the way, doing work that is just not going to be as fast as a static web server. It also means just as sites scale, I now have this, I might have my static content being served by this load balancer or server or whatever, and my dynamic stuff being served over here by these other servers doing different stuff. I've now put more load on my application servers that are doing that kind of work. I can't send it to Cloudflare or whatever, because Cloudflare isn't doing that kind of thing unless you use one of these things they've just released. So yeah, maybe I'm willing to accept that. And again, for any reasonable scale content, honestly, yes, I am. I'm totally willing to just say, you know what, my 5 lines of Ruby code in my Rails app for this PDF document to be sent, I'm totally okay with that. If that really isn't possible, you can do something like this. So say, well, I'm not going to do authorization checks on the file. I am going to serve the file as static, but I'm going to make the URL really hard to guess. In fact, effectively impossible to guess, right? I'm going to have a nice, good random number generator generate the file name that's kind of reasonably long and hard to figure out. And then I can let all my static content serving mechanisms, whatever they are, my content delivery network or something else. I know I haven't talked about content delivery networks yet, but I will later. I can let them deal with it. And now I'm kind of moving the security back a layer to, if somebody can figure out that URL or can find that URL, then they're going to be able to access the file. I now have to keep that URL private. So if you look at an image on Facebook, this is the kind of thing you get. You get not an image that's not coming from facebook.com, an image that's coming from, well, let's try YouTube actually. What happens if I go to YouTube? I have no idea. I don't even know who I'm logged into on my YouTube here. Okay, there's nothing offensive there. Right, so if I go to YouTube, can I get a, I just want the image. Oh yeah, open image in YouTube. There we go. This, I don't want to, I'm not advertising this video. I'm sure it's fine. So that image did not come from youtube.com. It came from ytimage.com, which is probably their content distribution network. And it came with this absurdly long URL. I was going to say file name. I have no idea if it's a file name, but it's a really long URL. If that was supposed to be private, nobody was going to guess this URL, but there we are. It's not secure in that sense, but knowing that URL is the thing that is not going to be told to any unauthorized user. Again, a little bit less security, but because anybody can access that URL. But again, at some scale, and this is why you see it on sites at this scale, that removing that little bit of logic from an image access is a win at that size. Okay. So yeah, like I said, I don't have an OWASP link explicitly for that. I suspect it's in 7. Nope, does the word static not appear here? I was hoping it would be one of these. But no, it's, I'm sure, somewhere in there. I'm not going to go hunting right now. Okay, so data storage in general. So again, back here I was talking about, okay, you have files, or file-like things in an object store like S3 or whatever, but files. But what about other data? In general, where is it? Who has access to it? Like, this is something that is, it's very easy to forget, I think, and I think especially, honestly, as a developer will tend to think about code. I have written good code, right? I have written all of these security checks properly, and I know that somebody who comes along and requests this URL is the only one who's allowed to access that record or file or whatever. Is it who's in control of the database? Like, if somebody can actually literally access the database, all of those things that you wrote with Laravel or whatever are not having any effect on the world. And you will see this once in a while. It's bad practice. It shouldn't be done, but some database systems will install Mongo with a default password, or with no password by default, and like open access by default. So that's like, it's in some sense user-friendly, right? So if a developer can just install a database and access it freely without a password, it's very easy to get set up, right? Your tutorial loses an entire section. It's a horrible, insecure default. Nobody should be that lazy that they're not willing to set a password for their admin user on their database. And then all of the other places that your data goes, who can SSH to the server? Do you know who all of those people are? Where do you put your backups? Are your backups somewhere secure, or are your backups just sort of sitting on some server where like everybody in the organization has access to it or whatever? This is, a little bit more of a system administration question than really what I've talked about in this course, but it's worth thinking about. It's easy to get it wrong. So maybe, again, I'm stretching a little bit to make what I'm talking about fit in the OWASP categories here, but maybe this is sort of insecure design, or maybe what I'm going to talk about next trends into the insecure design category. I haven't been looking at here. They have these average incident rate. So they did some kind of scanning for these things. Automated scans can't check everything, obviously, but yeah, maybe I should have been looking at those. Maybe they have a constant, like 3% of sites suck. I don't know. But again, I'm very suspicious of anything with 2 decimal places for these things. Like, you can't automatically check all of these things. So I'm very highly suspicious that they have checked all of these things in every way possible. Depending on the system you have, data is not all equally important data. Like, again, if you think about your Amazon account, I have an Amazon account that has my name and my address, and I would rather that not be, exposed to everybody. Like, my name and my email address and my mailing address, I would rather that not get exposed, but I would rather those get exposed than my credit card number, and Amazon has that too. So maybe at some level you have to have kind of separate tiers of storage. And this is, I guess, where the insecure design question comes in, where you do need to design your system so that there's a separate store or separate access control rules for these records or these tables or whatever it is. One of the things that it gets a lot of attention, and again, probably you're not, like, as a web developer, not the one dealing with password storage because you have some framework, some session management toolkit that's doing it for you. But I think it's worth mention because the simple fact is you can't control this. We all know, right? We all know we shouldn't use the same password on multiple sites. We all know we should, well, I hope we all know that. We all should have a password manager. I don't know. I have no idea what that password stored for this site could possibly be. You know, you've seen LastPass sitting up here in the corner the whole time. I don't know my bank password, and neither should you, but LastPass does. Anyway, but this is not true of everyone, right? People do use the same password on multiple sites because people have a finite memory for passwords. People can't remember 100 different passwords for 100 different sites. I don't know how many things I have in LastPass. I was shocked when I did this for my parents, like how few accounts they had. It's like, I have hundreds of things. They had like a couple dozen. It was adorable. Anyway, so the thing that, I'm drifting off topic. This goes wrong in a like systems, like design sense. If other website that I have absolutely no control over, user has the same password on that website and my website, and they have a data breach. An attacker can find out, you know, this email address and this password go together, and it's a pretty obvious thing. If you want to start getting into people's accounts, if you can find like this website username and password pair, try it on that website, pretty high likelihood of success. Somebody, oh, who was it? It was some like remote desktop app, TeamViewer, I think. There was a story of like TeamViewer has been hacked. Everybody's logging into TeamViewer accounts. And it turned out, no, TeamViewer had not been hacked. It was some other site had been hacked. So many users used the same password on that site and on TeamViewer, and some attacker just decided like, oh, let's try them on TeamViewer, and got into all of these remote desktop things. And it wasn't like TeamViewer ends up, you know, doing a press release. It's like, we didn't do anything here. People should have multi-factor authentication on, not use the same password. We can't fix it. And you can't fix it as a site owner, but you can not be the bad guy who affects others when, if your site, you know, your database gets exposed or whatever. So what you shouldn't do is have a table of users that's like user, you know, GG Baker password 1. Because then of course there it is. So people start to get this idea of, okay, that's actually my real password, honestly. I shouldn't say that, because people are going to try, and then like, I'm going to get like locked out of an account or something. I think I can do this. Aha. Good job, hashlib. This is the correct thing. The SHA-256 hash algorithm takes bytes as input. This is not bytes, it's characters. I think. Yeah. Okay. So this is a presumably 256 bytes encoded in hex of hashing that string. It's a cryptographic hash function. You know, it's hard to reverse. Still no. Because frankly, it's too fast. All of these cryptographic hash algorithms, or most of them, they're designed to be really fast. If you have a dictionary of passwords that you've ever seen anywhere in the world or that might be possible, you can do this kind of thing millions, billions of times per second and create a database of lookups, basically. See my 383 assignment on rainbow tables, I guess. But so it's very easy to make a dictionary of this well-known hash function takes this string and turns it into that. Salting and hashing a password is a little bit better. So actually, maybe I will sort of pre-encode that just so I don't have to repeat myself. Okay. Salting a password is doing something like this, where it's like putting some prefix on the thing and say, okay, well, on my site, here's how I'm going to encode passwords. And again, I honestly don't remember, is the salt supposed to go on the start or the end, or does it not matter? I would have to check that one. You shouldn't be doing this either. Maybe that I should give away the punchline. Don't do this. Don't try to think you're going to do this correctly, but a little tour of what correct might look like. Again, either it should be a prefix or a suffix. I don't remember. Okay, so then somebody else comes along and they don't know, they can't now rely on their dictionary of here's this string SHA-256 encodes to that, and then they can look it up the other way. But you can still check these, right? So if you know this is the prefix that this site uses for different passwords, you can still check. You can't sort of pre-compute, but you can check quickly on those. Don't want to let that happen either. And yeah, like this is moved to the archive, but this is fundamentally the lesson here. You are dangerously bad at cryptography. This is not an insult, because so am I. Don't try to do cryptographic things unless you're a crypto expert, and you're not. Let's hope that the nice Django or the Ruby on Rails or the Flask or the Laravel or CakePHP, let's hope that those people know enough and have followed some best practices and know the right function to sort of securely take a password that we see, do some arithmetic on it, and then come up with something you can actually store in the database to check later, in a way that even if my database leaks and some attacker gets that value, it doesn't really do them any good on any other website. So there are various, like, okay, I mean, Sophos is a reasonably reputable source of information. Nice description here of what they think you should do. Some of it is what I just did, like, oh, you could do this, but here's why it's bad. You could do this, here's why that's bad. I have seen students do this too, of like, oh, I did SHA-256 twice. Huh? Why do you think that's better? What makes you think that you know better than the people that created the hash algorithm? There are these hashing algorithms that are, okay, they recommend PBKDF2, catchy name. These hash algorithms are designed for passwords, and they're designed to be deliberately difficult, like deliberately slow to compute, because then you do eliminate this problem. Again, SHA-256 is a hash algorithm that's designed to be fast because that's its use case. Scrypt and Bcrypt and PBKDF2 are designed to be deliberately slow, so you can't check billions per second. So again, on your site, honestly, let the framework do it. If your framework doesn't have session handling for some weird reason, find a package that does. Use that. Don't do it yourself. Bad idea. This is also one of the things, I guess, as a user, or perhaps as like someone who advises users, your less technically adept friends or whatever. This is what the multi-factor authentication is doing, right? So even if you do know my SFU password, the hope of IT services is that you can't actually log into SFU things unless you also have my multi-factor authentication key token thing for like my TOTP, whatever it's called. Again, as a user, that's what that's about. It's even if somebody does learn my password on this website, it won't help them unless they also have my two-factor authentication app, or again, whatever token's stored in there. I guess one of the lessons for a developer here is actually do it. Like, your website should, in quotes, have two-factor authentication, at least as an option for users. So yeah, again, SFU has been pretty aggressive on turning on multi-factor authentication for their users, and I think with good reason, because this is one, like, I don't always agree with IT services, but this is one where they're right. All right, they know this. They know that people, I don't, I hope you don't, but there are people at SFU that use their SFU password on other websites, you know, whatever random e-commerce site that might get hacked tomorrow. How are we supposed to know? And then they can access GoSFU as that user. Well, hopefully multi-factor authentication is taking care of that. Or at least, again, mitigating it at least. And speaking of mitigating risk, life isn't perfect, right? You can follow all the best practices in the world. You can be very careful with your security, and you should. But there's, of course, always this possibility of, you know, when I say back here, you know, let your framework handle the authentication. Users log in, username, password. Your framework has some concept of, hey, this user has come along and presented this username and password. Should I let them in? Yes. Okay. And, you know, set up the session. Maybe there's a bug in there, right? Maybe next week there's some like, oh, it turns out we used totally the wrong hash function, or the comparison was a little funky, or whatever. And users will be able to access, and it's sort of out of your control, even though you've done all the right things right. Although, speaking of, one thing I didn't mention there, that maybe I should, is this vulnerable and outdated components, right? So, hey, somebody found a problem with the framework and the way it does authentication last week. Well, maybe I should have updated my framework in between then and now, because there was a vulnerability in that old thing. And actually, I do notice here the incident rate is higher here. One, because it's easy to check in an automated way, but two, because, yeah, like, keeping every possible dependency up to date is some risk, is some work. So how do you so mitigate is like, how do you minimize, I guess, the impact of that problem? Again, whatever it is, right? Your user reuses a password on another site or whatever. How can you minimize the impact of that on your site? Leaking data is bad. You can't get it back, right? If you leak data, it's out there. The thing you can do is leak the minimum data possible, right? So, like, I can log into GoSFU and I can see the grades of students who took my course last semester. That seems reasonable, right? I might have to go in and change their grade. I do need access to that information, or even just the fact that that person did take my class last semester. I need access to that. It's part of my job. What I don't need is to know what other courses that student took last semester, or what grades they got in other courses last semester, and I can't see that, and that's as it should be. So if my account gets hacked, okay, that's bad. That shouldn't happen. I have a good password. I have two-factor authentication, but even if it did, it doesn't affect some English student, you know, who has never taken a class from me and doesn't have any idea who I am. Which this can be hard, and it can be hard to do in a like non-technical way, just in a like organizational way. Yeah, you trust your users, right? You know that this user is a good person and they're a trusted manager or whatever. It's not that you don't trust them, it's that you don't trust their account. And it's really hard to communicate that sometimes to people, of like, I'm not going to give you access to every record that your department has because you don't actually need it. And need is also a funny word. People say they need a lot of things. Again, this is a partially system design. Just people should have access to as little as possible in general, right? If things go wrong, the impact should be minimized. Okay, so if, let's say, so my account gets hacked and they go to GoSFU and they start changing everybody's grade from last semester to an F. Okay, that's bad. People would probably notice. Like, so students would probably notice that they start getting grade changes to Fs or whatever. Actually, there's an approval process on those grade changes, but let's ignore that. Let's say people start getting Fs. Well, does GoSFU notice? Like GoSFU, the system probably has no like how would they monitor that? I guess like if over some certain threshold of grade changes happen in a certain amount of time, but sometimes that does happen because there's a whole bunch, like there's just a like mass marking error. The TA was, did something wrong and we have to change half the class's grades. That happens once in a while. Is there any kind of monitoring, logging, or, okay, when this happens, students start getting Fs for my class last semester and they start, complaining here, there, and everywhere. Can we fix it? Can we figure out, well, what grade did they have before that? Okay, like this student had a B+, then they had an F. I want to change it back to a B+. Is that data somewhere to recover in either an automated or a manual way? Hopefully, yes. Hopefully there's some history there. And again, we get back to a question of system design here. And again, something that is in the control of a developer. The easiest thing to do when you're creating a thing, your project for this course or whatever it is to say, okay, well, again, we have some concept of like an order or a post or whatever it is, and I'm going to have a table. Let's say blog posts, right? Since there's so many tutorials that are blog posts, we're going to have a table called post or an ORM object called post, and it has a title and contents and an author. And then, oh yeah, we do want users to be able to edit their post. So we have an edit button, and edit overwrites that row. That's okay. You're going to be able to display the correct current record. But again, malicious user comes along, or again, it might not even be a security thing. It might just be like an angry roommate comes along and goes and sits down at the computer and starts editing, deleting, or whatever. Can you recover from that? Well, if you have a revision history and if you have revision history, it's pretty easy to say like, okay, well, I have every possible revision of this post. Take the one from a week ago and kind of promote it back to the current. You have basically your like revert or undo kind of functionality. That's cool. And there have been cases where, like there was a case in Courses where Courses keeps a revision history on all grading activities. I can't show you because it would be actual some students' grades, but it does keep a history that I don't think is visible to students, but it is visible to instructors of like, okay, assignment 1, this TA marked it, and then the instructor changed it and the TA changed it back or whatever. It just keeps all of those. So even manually, at least you can look and say, oh yeah, a whole bunch of these got changed incorrectly because of a data entry problem or something malicious or whatever. We can at least see the history and recover. Some kind of like database snapshot or keep a log of all like the binary log of all the transactions that some databases can do. So you can just sort of rewind the database to this point in time, or dump the database as it was like 1 second before the attack started, so you can at least see what's going on there, or an hour before because that was your most recent snapshot. Just having that data can be a huge thing if the time comes. Some kind of logging, and like maybe I'll come over here, this like security logging and monitoring failures from OWASP. I see, again, I think 6.5% is radically too low for this one. It's very hard to know what you need to keep an eye on. What information do you need to log? Like, okay, the user logged in, they typed this, or they changed this value, they changed that value, they logged out, they logged in again. Okay, it's very hard to know exactly what you need to log for every situation that you have to investigate. And again, whether it's security or it's a question of site performance or just, hey, what is this user doing? Were they exceeding, their job authority or whatever? Very hard to know what that can be. And again, monitoring. Does GoSFU monitor that I all of a sudden start making 1,000 grade changes? I bet they don't, because why would they? That's such a weird thing to monitor. But maybe. So yeah, I think I would say that not logging and monitoring everything is 100% of sites. Like there's going to be stuff that you, sometime a year from now, every website is going to wish they kept a record of, did the user do this or that and when. Maybe for like privacy invasion reasons, but maybe again for security, for site reliability reasons or whatever. Was there anything else in here? Yeah. Okay, I will leave their attack scenarios to the side. And maybe I will look here. Okay, so on the 2021 list, how have I done as the lecture goes? Broken access control. What's cryptographic failures is, I guess this is not using HTTPS. Don't transmit things that are not encrypted. Sure. Yeah, like our passwords being used as cryptographic keys. Okay, sure. I'm just wondering. So I want to know here if there's any big things that I have missed. I talked about injection, insecure design. Yeah, I mean, obviously there's things about insecure design that I haven't talked about because it's such a huge like category. So yeah, storing passwords in a recoverable format. Okay, so again, the sign of this is often, if you're talking to like a tech support person from whatever website and like, oh, I forgot my password, can I reset it? And they say, oh, your password is password 1. This is a sign that they can see your password, and they should not be able to. That should be technically impossible. Improper privilege management. So again, this is, I guess, what I talked about back here under mitigation, minimum data they need. Maybe not. I guess this is insufficient authorization that I talked about. Somewhere in here will be, I guess maybe it's incorrect privilege assignment. Geez, that's a good one. Because like my experience is user, like if you allow a user to assign privileges to other users, like managers can say this person's my employee, give them access sort of deal, they will, and they will do so indiscriminately in a way that perhaps a more security minded actor would not. Okay, where was I? Okay, so security again, some of the things, I guess, I talked about more system administration related things here. Maybe this falls under security misconfiguration. Yeah, the ability to log in where you shouldn't be able to log in. Outdated components I talked about. I feel pretty good about how I've done down this list. Yeah, server-side request forgeries is a bit of a niche. Apparently, it was voted for when they did a survey. But this is like the user gives you a URL and you request it on the server, which is, okay, something you should not do casually, but I don't know if it's all that common. Yeah, I think I'm okay with my coverage on that list. So this collection of links, I've collected a few of these here and there. There's nothing magical about this list, but just a few things that, yeah, like election systems hacks. This is from the States, like, oh no, people are voting or whatever. The problem was like, this is an insecure system. It's a system that allows SQL injections and shouldn't. Whatever this article talks about, like Democrats and Republicans or whatever, isn't the point. It's a bad system. It's bad software, nothing about politics or anything else. The Have I Been Pwned is just a general site. Like it's a, so Troy Hunt, who is the proprietor, kind of keeps this like every possible breach that he can get his hands on and all the data and catalogs it. So you can check to see like, has my email or phone number or whatever been compromised and is in some, that this email goes with this password or this mailing address or this name. So you can search for yourself in there. If nothing else, actually, there's Troy Hunt was interviewed on the Phil DeFranco vlog. If you're at all interested in security, or even not especially, like if this is not your thing and you're a more casual, you have more casual interest, I guess, in security, the Troy Hunt interview on the Phil DeFranco vlog is worth listening to. It's a good, like, he does a good job describing these things to an audience who is not highly technical, and good for him. This passport applicant, this sends chills down my spine. This is just again, insufficient authorization. Like, there's a number in the URL, and if you change the number, you see somebody else's passport application is kind of a big deal. The reason this sends chills down my spine is it was Passport Canada. Like, somebody did this wrong, and I bet I'm like not more than 2 or 3 degrees of separation away from that person. Like, I just hope it wasn't a Compute 470 student. Don't be doing that. I don't want to see your name in some newspaper article in 5 years. This Equifax breach, I mean, it was a huge breach. This is a crap explanation from the CEO, right? Like, if there's a single employee at Equifax whose job it is to update the whatever it is, Java struts deployment, this is a massive organizational failure. It's not a failure of that one employee. That one employee maybe should have done it, but the organization where this is such a critical thing to have your data stored securely should have had more than like, oh, Bob, it's Bob's job to do that. We assume he's probably going to do it, whatever, it's fine. Yeah, so the technical problem was trusted input. The organizational problem was much bigger than that. Okay, that is probably a good spot to stop, if nothing else, because it's the end of my slide deck and we are coming into this. So the next couple weeks lecture will be the technology evaluation presentations. So I don't know, about a third of you will be sending me videos for presentation next week. Like I said at the start, I will put those together into lectures in the same kind of format we're seeing here, just with somebody else's videos cut together. I don't know. Anything I have to say at this point is important enough that I will send it by email. So you will have received email from me about those presentations and how to deal with them and how to get them to me and everything else. So I will stop there. See you next week, and we'll hear from some of your classmates, and have fun between now and then. Bye, everybody.